Hey there, hey there, hey there. So welcome to the chemistry algebra review. We do use some of those algebra skills you learned in Algebra 1. 2x plus 1x equals 3x. Dividing the 3 over, taking the reciprocals of things. So we're just going to do a quick review. You have these notes, hopefully from your teacher, as we go. So we use ratios a great deal. A ratio is just a fraction written that represents two different compounds or two different substances. Sometimes though you need to flip the ratio over and different things. So let's talk about algebra though for a couple minutes. So anytime we have a fraction in the denominator, remember the denominator is the bottom half of the ratio. We can simplify it by inverting it. So what I like to say is this b is in the denominator of the denominator. So it's like 1 over a over b. So a over b is in the denominator, and then b is in the denominator of that. So if it's in the denominator of the denominator, then it gets flipped back up and it becomes the numerator. So you see how b jumps back up to the top. It doesn't make much logical sense unless maybe you have an example with real numbers to kind of support it. So here we have 1 divided by 1/2, and that ends up equaling 2 over 1. So this guy that was in the very bottom becomes the top, and there you go. Because we all know that 1 divided by 1/2 is 2, right? Because 1/2 goes into 1 twice. It's 2 1/2s in 1. Here's another example of the same idea. Here we have c in the numerator, and it's in the top of the denominator there. And so these two c's cancel out. This d was in the denominator of the denominator, so it ends up getting flipped up to the top. So c over d equals just d. Warning! You cannot cancel x out in this scenario there, where x plus y or x plus 2 or x plus 5. It doesn't work like this. You cannot do x and x's cancel and just end up with 1 over y. That is not true. The easiest way to test whether or not something is true or not true is to just take simple numbers and plug them in those spots. So say x is 2 and y is 3. Let's see whether or not these two are equal or if they're not equal. So that's what I did over here on the right. I have 2 over 2 plus 3. Well, 2 plus 3 is obviously 5. So 2/5. And then in the other one you'd have 1 over 3. And those are definitely not equal. So that further shows that we can't just cancel out the x. We'd have to do some more algebra to simplify that down, which is really beyond the scope of this particular class. When you're multiplying two ratios, you multiply and divide the numbers and the variables and then simplify them. This is one skill we will definitely use a lot when we get into grams and meters and molarity and moles and a bunch of new terms. Terms are going to be new and unique just to chemistry. So first you gather everything together. We have f times g on top. We have g times 2 on bottom. So now you see we have g on the top and the bottom. So those two can cancel each other out. And we just have f divided by 2 left over. In the next one we have on top, we have 3g and 4n. So you can even just connect these together. So you have 3g times 4n. So 3 times 4 is 12, g times n. On the bottom we have 1 times 2 times g, that's 2g. And then the 12 and the 2 can be simplified down to be 6 and 1. And this g and that g cancel, and you end up with just 6n. And the third example, got a lot more going on. Even this example here on the quiz would be no calculator. You should be able to do this type of math in your head as an adult on the planet. So let's handle this here. 3 times, it's just kind of connected all together. Top is 3 times 7 times 28, 3 times 7 times 28, y times x squared times s, y x squared s. I'm just kind of moving the numbers around so that all the numbers are together. On the bottom we have 1 times 6y times 14. And now we can simplify some of these before actually trying to do the math. So we have, let's see, 3 over 6. That could be changed a little bit. What else could we simplify? Oh, here we go. We have a 7 and a 14. Those are both divisible by 7. So this would become 1, and this would become 2. All right. And then what's 2 times 2 is 4. And see, 28 is the same as 4 times 7. So we can take this 2 times 2 and cancel out this 4. The only thing left on top is the 7. So we simplified all these numbers down to 7 over 1. Then we get to the variables. We have a y over a y. Those cancel out. X squared over x. Do you guys remember? X squared over x to the first. They don't have the same number of x's. You could also think of this as x times x over x. So only one of these x's is canceled out on the top and the bottom. There's still an x left on the top, which is why we still have an x left here, and the s isn't canceling at all. So you're just simplifying it down, canceling out like terms. Here we have some algebra problems. Remember, with algebra, you're trying to focus in and solve for one single variable usually. And this is heavily dependent on applying order of operations, usually in reverse order to get down to that thing. So we're going to need to divide the 2 out, but first I'm going to move that 5 over. Since the 5 is being added, the opposite operation would be subtracting it over. And the big key to this was, whatever you do to one side, make sure you do it to the other. So to get rid of this 5, I have to subtract 5 from both sides. If I subtract it from both sides, then the 2 sides are actually still equal to each other. So on this side, 5 minus 5 is 0, so there's no single numbers over here. But 13 minus 5 is 8. Then I, of course, have to get rid of that 2. And if I divide the 2 off on this side, I have to divide the 2 off on that side. So I found out that x was equal to 4. Of course, if you're not sure whether you did the math right, you can always plug it back in and go 2 times 4 is 8 plus 5. Yeah, that equals 13. In the second example, I'm going to rewrite this as x over 2 is equal to 8 plus y. The x is almost by itself, except it's being divided by 2. So I need to get rid of that 2. What is the opposite of division there? You in the back, you're right. Good job. I like your hair today. It looks good. You have to multiply both sides by 2. Why both sides? We're trying to keep both sides of the equation equal. If we do it to one side, we have to do it to the other side equally. So then I have, let's say, 2 times 8 plus y. What does this 2 have to do? You could distribute that 2. Remember distribution? That was fun, wasn't it? So 8 times 2 is 16. Y times 2 is 2y. So x is equal to 16 plus 2y. I guess technically once you had moved the 2's over, you had solved for x, and maybe we go a little further. All right, and then this example was also in there. So we have solve for x sub 1. That is not x to the first power. That is one type of x, whereas x2 is a different type of x. This is truly a ratio. Maybe this is velocity over distance or volume in moles, which you don't know what moles are yet, but it's a ratio of two things. And we're trying to solve it so that x1 divided by 1 is equal to all the other stuff. So x over 1 is equal to all of the other stuff. So we're going to go through a couple of steps. That first step is to get this to the top. We cannot have it in the denominator. It has to be in the numerator. So multiply both sides by x1, and that would move, it would cancel the x1s out on this side, x sub 1, and you'd end up with x sub 1 on that side. And let's see, what else could we do? We get rid of this v. We don't really want v times x, we want x by itself. So I'm going to divide the v2 over to the other side. That cancels this v2 and that v2. And here was the second step. I got a bunch of it done. I moved the x's and the v's. So you could see we have v1 over v2 and x1 over x2. And it really, you could think of that as we just cross-multiplied the two pieces. The v and the x just switched places. That's usually what people do. The last thing I guess I want to focus in here is getting that x2 to the other side. x2 is in the denominator, so I need to multiply both sides by x2. And so then you end up with x2, v1, and v2 is equal to x1 over 1, or just x1. So that's a real common one. That's something we might do. Solve for a variable, carefully cross-multiplying. Carefully cross-multiplying. Again, it's always nice to have a simple tool in your back pocket for handling these things. Like 6 over 2 is equal to 3 over 1. So we were just saying maybe you could cross-multiply these two terms, just like we did with the x and the v. So let's try that. 6 over 3 is equal to 2 over 1. Oh, that's true, yeah. And then we could even move these two terms. There's lots of things. You can move across the equal sign, and you're still technically legal. So 6 times 1 over 3 is equal to 2. You know, there's lots of ways to move across the equal sign. Just remember, if you're in the denominator, you're multiplying to the other side. If you're in the numerator, you're dividing to the other side. All right, you probably want to pause and practice these problems before I go over these answers. Here's your opportunity to pause. All right, now that your Panther pause is over, let's do some answers here. So first, let's simplify this. We have 12 divided by 4, so that's 3 over 1. We have the numerator and the denominator. Ooh, this b is in the denominator of the denominator, so we're going to end up with that in the numerator. So we have 3b over 1, or maybe just 3b. Number 2, f is not going to get canceled out. It's going to stay in the denominator. But 8d is in the denominator of the denominator, so it's going to get flipped up to the top. So we'd have 4d times 8d, which is 32. What happens to the d's? They're multiplied, so that's d times d, or d squared. D squared, for those of you who don't think that's funny. Here we have a couple. We're supposed to simplify them down. Let's knock out what we can. Let's see, we'd have 9 times 18 times f times y times I over 1 times 3 f y. Ooh, what about this 2? It's in the denominator of the denominator, so it's going to flip back up here. So it's actually one of the numbers on top. So now that we have everything on the correct side, let's do some simplification. It's not too bad. Here we have a 9 over a 3, so we could simplify that down. Here we go. It becomes a 1. This f and that f cancel. This y and that y cancel. So I have 2 times 3 times 18. 2 times 3 times 18. 2 times 3 is, good job, 6. Is 18 times 6? 18 times 6. Let's see, 6 times 8 is 48. Carry the 4. 6 times 1 is, that's 108. So we have 108 I. It's my attempt at an I. Let's see what else we can do on the next one. Let's gather these things together. We have 2.5 times, this has to be added first because it's in parentheses. That would be 18. And then we have an M and we have a G. On the bottom, we have a 3 times 1 times L times M. So we can simplify this down a little bit. We have 18 over 3, which comes 6 and 1. So at least we know the bottom is a 1. And then we have 6 times 2.5. Ooh, some people are going to struggle with this one. Let's do the math in slow motion. So what's 6 times a half? It's half of 6. 3, very good. Right. And then what's 6 times 2? Yes, you with the hat? Yeah, 12. 12 plus 3, 15. All right, there we go. And then we need to simplify some things down here. We have an M over an M. The G and the L don't cancel, so I'm just going to turn this 1 into an L. So 15G divided by L. Here we go. And then lastly, solving for T. These guys are all being multiplied together, so how do you get rid of them? You divide the N and the R over to the other side. So this is an equation we'll actually use later in the year called the ideal gas law. So pressure times volume divided by moles in R, which is called the gas constant, will tell us the temperature. More on that quite a bit later. There's a couple ways to solve number 6. What way do you want to use? Yeah, that's what you want to do? Okay, well, what was suggested by the person in the giant sweatshirt in the corner was to move the 2 over and multiply both sides by 2. It's a good idea. Multiply this side by 2. Oh, but we're going to have to put parentheses around. We can't just multiply one piece of the other side by 2 to double everything. So that means 2 times 25 is a 50. And then 2 times 3 is 6t is equal to just t. Now we need to move the t's to the same side, so I'm going to subtract. Why did I pick subtraction? Well, here it's being added, and to move it to the other side, I have to do the opposite operation. I think we all agree that subtraction is the opposite of addition. So I have 50 is equal to, what is t minus 6t? Negative 5t. We're getting closer. Now I need to divide both sides by negative 5 to hone in on the value of t. T is equal to negative 10, which I didn't plan that. I just typed something up and it happens to be a negative number. If we were not certain we did this correctly, we could come back up here and plug it in and make sure it works. 25 plus 3 times negative 10 is equal to negative 10 divided by 2. Yes, yes it is. This would be negative 5 because it'd be negative 30 and 25. And this would be negative 5. So we did it correctly. T is in fact equal to negative 10. So that about wraps it up. Algebra is required. Don't worry. Be happy. You're going to do well on this quiz if you thought this was easy. If you did not think this was easy, you need to get some help from your chem teacher ASAP. We are available for school, after school, every alternating Thursdays, even Fridays. Now, we're available and we're available. Ask your teacher when he or she can help you, or ask a different teacher for help. We work with all kinds and all students. So good luck on the quiz and see you in the future.